All right, Algebra 2, Lesson 21, solving systems of equation using the substitution method. Up to this point, we've solved systems of equations by graphing. We've used the Cramer's rule. I'm trying to think if we've done anything else up to this point. We've done matrices, haven't we? Right, you could solve a system of equations using matrices. So this is number 4. You will also eventually end up learning the elimination method, okay? So there's like 5 different ways that you can solve a system of equations. In the end, if it came down to a test or the ACT or something like that, I would tell you solve whichever way you're comfortable with, or whichever way is going to require the fewest number of steps to get where it is that you want to go. Okay. So one way a system of equations can be solved is through graphing. We've done that. Sometimes the solution to a system may be difficult to determine on a graph, especially if the solution is an intersection point where the values are fractions or decimals. Two lines don't always intersect at these nice neat coordinate points where it's like 4, 3, or 1, 2, or 0, 0, right? Sometimes 2 points could cross at a radical, right? They could cross at a very finite decimal, okay, or an irrational number somewhere, okay? However, there is an algebraic way to find the exact solution of a system of equations. That's the substitution method. And it arranges equations from a system in a way that produces a one-variable equation by substituting variables with expressions. Okay? So if a system of equations forms intersecting lines, the equations have one common solution. We've seen this exact same chart. This is like the 4th time we've seen this chart where it's telling me consistent, inconsistent, dependent, independent, right? Is that new information to us? Shouldn't be, right? When solving these independent systems algebraically, the result is a coordinate. So we want to recall that there are 3 types of possible systems, okay? Either they cross, they're parallel, or they're the same line. Those are the 3 possibilities, okay? So we have intersecting lines, coinciding lines means that they're the same line, and we have parallel lines. This is actually a pretty handy chart. They've seemed like every time we cover something like this, they give me the chart, but they do it differently. I like this chart about the best, just because, I mean, it breaks it down into the 3: consistent, independent, consistent, dependent, inconsistent. In this sense, with parallel lines is no solution. Okay. So if a system of equations forming coinciding lines, okay, that's our middle, the equations are describing the same line. Thus, all the points on the line are solutions to the system. When solving these dependent systems algebraically, the result is a true numerical statement. Basically, you're going to get down to something where it's 0 equals 0, 5 equals 5, 7 equals 7, -8 equals -8, something like that, right? That's going to tell me that my lines are overlapping, is whenever I reduce it down and I get a number equals that same number, okay? Now, if for some reason I got a number that didn't equal another number, I'm probably dealing with parallel lines because there's no solution. It's untrue, right? Okay. All right, so that's it for that. Let me see if I have... I don't know if this is the right thing or not. It may not be. Nope. Okay, so what we want is Algebra 2, Lesson 21, 22. And we'll try to just cover the questions that are going to cover what we need to cover today. Which it looks like at least our first, actually all of these. So all of this does anyway. Okay. All right, so solving this system using substitution. What we're effectively saying is, notice that this equation is y equals, right? Because it's y equals 2x plus 5, that means I can substitute in for y in the upper equation. So I can write that as -4, use a set of parentheses, 2x, good? Okay, so now I've got it down to where I'm just solving for just one variable. Okay, from here, Danielle, what would you do? Distribute what? Okay, tell me what I get when I distribute the negative 4. Negative 8x. What else? Negative 20. Okay, good. Equals negative 20 minus 8x, right? Okay. What do we notice about both sides of the equation? They're in a different order, right? But could I rewrite, let's say, this side as this, right? And if I went and I added 20, from here to here, right? And I added 8x from here to here, what would I get? 0 equals 0, right? So what do I say in that case? Is it no solution? It can't be B or C, correct? Right? Is it no solution? No, it's not no solution. Okay? So what we're seeing is that this equation here, if I reduced it or if I converted over to slope-intercept form, equals y equals 2x plus 5. And we can see that. Let's go ahead and actually do that. All right? That would require me to divide everything over here by negative 4, correct? So y equals, okay, well, what's negative 20 divided by negative 4? Positive 5. And what's negative 8 divided by negative 4? Positive 2x, which I would write that as y equals 2x plus 5, right? All right, so that's why I'm getting A as an answer. Both those equations equal 2x plus 5. Does that make sense? All right, you might see that question on a test, so I want you to be aware of how to work it out. Okay? All right. Let's see. I don't think we want 2. 3 goes with the next lesson. Let's see if we can find another question that's going to deal with something that we actually want to deal with. All of this is next lesson stuff, and it doesn't. Yeah, 21. Everything else is 22. Okay, well that's a problem. Yeah, I mean, well we can. Let me just double check and see if there really is no. For some reason, no 21 shows up in here. I don't know why that is. Okay, well I'm going to hit pause for a second. All right, so we just made one up. If it will scroll for me. Does not appear to be. I can look at it, but it won't let me scroll. Okay, well, in this event, what I'm going to do. Oh, hey, here we go. Now we're moving. All right, let's look at question number 2. Wants us to solve this system of equations by substitution. So what am I going to do from the lower equation to the upper equation? Okay, so we've got 3x plus what? Plus x plus 5. What does it equal? Negative 3. Okay. Somebody besides Axel. Let's see. Jewel, can you tell me what I would do from here? 3x plus x plus 5 equals negative 3. Subtract what? Subtract 5. Okay, so we can subtract 5 from this side over here. So that's going to give me, I got 3x plus x equals what? What do you get with that negative 3 minus 5, Jewel? Negative 8. Okay. All right, what's next? Anybody? Okay, how many x's do I have? Got 4x equals negative 8. Divide by 4. X equals negative 2. All right, now that I've got x equals negative 2, what do I do? Plug it into this equation here is what I would do. So you got y equals negative 2 plus 5. So what does y equal? 3. Now I'm going to put it in as a coordinate pair. What number goes on the left in my coordinate pair? Negative 2 and 3. Okay, so I should get B as an answer. Does that make sense? I feel like it's self-explanatory, right? It's fairly easy, right? Now, yeah, but number 3 takes it and it gets a little bit more difficult, right? You can do it. All right. Why is 3 more difficult? I can't even pull it up now. It's going to think about it for a while. Okay. Sometimes technology is not all it's cracked up to be. So number 3 looks like this. Oh, okay. Now we can look at it. All right. It always proves me wrong. I try to do something else. All right. Why is number 3 more difficult? It's not? It's not more difficult? Why not? Okay, I'll let you write it down. On our previous 2 equations, at least one of those equations was already set up to solve for a variable, right? Are either equations in number 3 set up to have solved for one single variable? No. Now, which one would be the easier one to solve for a variable? The bottom one. What would I have to do with the bottom one to get it to be equal to a variable? I would just add 2y to both sides, right? X equals what? 2y minus 12? Is that right? Yeah, just move that over. Okay, but it's not already there, which means I do have an extra step involved. Okay, now instead of substituting for y, what am I substituting for? Substituting for x. So I'm coming up here, I got 4 times 2y minus 12 minus 4y equals negative 16, right? We're working this out as we go. Can I erase this x equals 2y minus 16? Or minus 12, sorry. Okay, so now we're back to using distribution, right? 4 times 2y is 8y. 4 times negative 12 is negative 48 minus 4y equals negative 16. What do I call my next step? Combine like terms. All right, 8y and negative 4y is 4y minus 48 equals negative 16. Add 48 to both sides, right? When we get used to using that terminology. 4y equals, is it 30? 32. All right, 4y equals 32. Divide by 4 on both sides. Y equals what? Y equals 8. Okay, now what do I want to do? Okay, plug it back in, solve for x, correct? Okay, except in this earlier equation that we wrote x equals 2y minus 12, correct? So if I kept that equation, all I have to do is do x equals 2 times 8 minus 12, right? All right, what's 2 times 8? What's 16 minus 12? 4. Okay, so as a coordinate pair, I'm getting 4 and 8. So I get D as an answer. Okay, does that make sense? All right, number 4 is pretty well the same way. You'll notice in here that neither one of them solves for a variable off the beginning, so I'm going to have to rewrite the equation to solve for that variable, right, and solve from there. Okay, does that make sense? Okay, what I want you guys to do is I want you to solve number 4. I'm going to hit pause on the video. All right, I want to see how well you guys can do on your own on a more difficult question. All right, to see how well you guys do. Do you guys want me to leave this work up here while you do that? Okay, just so you have something to look at. Do your own work on number 4. I'll come around and check it. All right, so we've had a little bit of time to look at it. I'm going to go ahead and clear this out. All right, so we wanted to start with, let's see what we're looking at here, number 4. Number 4. Let me slide this over, give us a little bit more room to work. Okay. Let's see. Did you take the top equation or the lower equation to solve for a variable? The top equation. And what did you solve for? Did you solve for x or y? X. And what did you get? You got x equals what? X equals negative 3y minus 3. That is correct. That's what we should get. X equals negative 3y minus 3. Okay, so then we want to take that and we want to put it into the other equation, right? So we've got negative 3 times negative 3y minus 3 minus 9y equals 18. Okay, so you distributed, you had negative 3 times negative 3, that gave you 9y. Negative 3 times negative 3 gave you positive 9. All right, then you had negative 9y equals 18, correct? What happened when you combined like terms here?
9 equals 18.
Yeah, you got, I mean, basically your 9y's canceled out and you got 9 equals 18, right? So is that a true statement? No, it's an untrue statement, which means what's my answer? No solution, therefore it's inconsistent. Okay, which means these are parallel lines, right? Okay. Gotcha. Okay, so do we understand what we're looking at with something like that? All right, let's see. Do you guys want to cover a word problem? Just something like this. Here, let's look at this one. This one I got kind of a star next to. It's number 6 on here. I haven't actually shared this document with you, so you can't pull it up. Now, if you want me to, if all said and done, I can send this to you. But this table shows the increase of the populations of the cities of Martin and Taylor from 2005 to 2006, and it gives you actually the increase. Shows you what the increase is. If the population continues to grow at these rates, in about how many years will the two cities have the same population? That means where are the lines going to cross at? Okay, what year? Round your answer to the nearest 10th. Okay, so see if I can help you out here. Is that we want to know where they equal each other at, right? Okay. So let's do this. Let's say we've got 817961 plus, and our increase is 1928. 1928x. That's going to be equal to basically the 2006 and their x. So 783,377 plus 10,597x. Okay, looks a little crazy here. But what we can do here is that we can solve across. So like if I subtract, let me see, we got this and this, I would want to subtract this 780,377 from 817,961, which is going to leave you with 37,624, okay? And let's see, we want to subtract 1,928 from 10,597, which is going to leave you with, and my number I can't read, what's 10,597 minus 1,928? I don't see anybody punching it in a calculator. It's like 8,666. No? I want this number right here subtracted from that number, or better yet, subtract this number from this number. Okay, so you're not having to read my 8,669 x. All right, now if I want to solve for x, right, what do I have to do? Okay, so 37,624 divided by 8,000 669. X equals what? 4 point what? All right, let's call it 3. Okay, round your answer to the nearest 10th digit. So 4.3 years is how long it's going to take. Okay, because the two equations have to equal each other. So y equals, slope and y-intercept. Y equals slope and y-intercept, set them equal to each other, right? Because they've got to cross. So it's not necessarily, we didn't really actually use the substitution method here. We just set the equations equal to each other. The rest of these equations that you see through the rest of this list follow what you've already done, right? You guys have already done these types of questions, okay? So what I'm going to do is I'm going to set you loose, and I'm going to send this document to you, okay? All right, that way you've got the answer key and you can take a look at it.